Dear students, in previous class discuss in 15th group of general properties. Today now we are going to discuss about in 15th group only nitrogen elements. In this concept we are discuss about how to preparation of nitrogen, properties and uses of nitrogen. So that's why today first we will discuss about the preparation of nitrogen. So how to preparation of nitrogen? There are various methods are there, children. So one of the method, it can be prepared by fractional distillation of air. You know, air contains 78% by volume of nitrogen. That is why the major component present in the air is nitrogen. That's why as one of the method is using preparation of nitrogen by fractional distillation method. We are using the substance here, air, the fractional distillation of air to form the nitrogen. This is one of the method. And another methods also, especially in the laboratory, it is prepared by aqueous solution of ammonium chloride with sodium nitrite. So ammonium chloride formula NH4Cl, sodium nitrite formula NaNO2. What happens here? You know, opposite charges are combined. Here Na plus combines into Cl minus, one of the product sodium chloride. And also here liberation of nitrogen gas and also formation of water molecule. So this is also one more method, preparation of nitrogen in the laboratory. How to prepare, children? Aqueous solution of ammonium chloride is reacts with sodium nitrite formula NaNO2. Children here, clean observe here. Sodium nitrate is there, nitrite is there. This is nitrite, NaNO2. Nitrate means NaNO3. That is why we are using sodium nitrite. Then formation of nitrogen gas along with these byproducts. This is one of the laboratory method. But in this preparation, nitrogen contains some impurities. So that's why a traces amount of impurities. Which are impurities are present? Nitric oxide, NO, nitric acid as impurities with nitrogen gas. That is why further nitrogen gas, it can be removed here, it can be passed through aqueous H2SO4 solution containing potassium dichromate, because you need for pure form of nitrogen. That's why to remove the impurities, further this nitrogen gas passed into the aqueous solution of sulfuric acid which contains potassium dichromate. Then it gets the pure form of nitrogen. That is another method. And one more method also, children, is for preparation of nitrogen, that is called decomposition of ammonium dichromate. This is formula of ammonium dichromate. NH4 taken twice, Cr2O7. Ammonium charge is +1, but dichromate charge is -2. That's why balancing here, NH4 taken twice, Cr2O7. Here decomposition, thermal decomposition means by heating. Then ammonium dichromate on heating, here product, one of the product, major product, nitrogen gas, chromic oxide, Cr2O3 and H2O is formed. Okay, children. And one more, directly pure nitrogen can be also prepared. In that purpose, again you are using decomposition of sodium azide. This is called sodium azide. Formula NaN3. This is called barium azide. Either using sodium azide or barium azide. In this process also decomposition to get the pure form of nitrogen directly. Earlier also prepared nitrogen gas but contains some traces amount of impurities. But in this case no need any impurities. Directly you get the purest form of nitrogen gas. That purpose you are using two substances, either sodium azide or barium azide. Sodium azide formula NaN3, barium azide formula BaN3 taken twice. Because of barium is a second group element, it is a bivalent. That's why taken as twice. But sodium is monovalent, taken as NaN3 only. So both are here decomposition to get the pure form of nitrogen. So children, these are the various methods preparation of nitrogen. Understand? One is prepared by fractional distillation of air. One more is about prepared in the laboratory aqueous solution of ammonium chloride with sodium nitrite, and third method is about the decomposition of ammonium dichromate, and fourth method is pure nitrogen can be obtained by decomposition of sodium or barium azides. How many methods are there, children? Total 4 methods are there. So these are the preparation methods of nitrogen. Understand, children? So now children goes to discuss properties and uses of nitrogen. So now properties, physical as well as chemical properties. So nitrogen is a colorless, tasteless and non-toxic gas. That's one of the physical property. Second one, it is a inert nature at room temperature. Inert means there is no chemical reactions with the other. But why are inert nature? Due to high bond enthalpy of nitrogen molecule. So in previous class discussed about the structure of nitrogen. So that is nitrogen and nitrogen elements here exhibits a triple bond. Here triple bond means multiple bond. Here the bond dissociation enthalpy is very high, breaking of the bonds. That is why at room temperature it behaves as a inert nature. But whereas at a high temperature, what happens? Combines with either metals or non-metals also. If combines with metals, the formation of the compounds are called nitrides. N-I-T-R-I-D-E-S, nitrides. I'll give you some examples. Here metal of lithium combines with nitrogen, they form lithium nitride, Li3N representation of the formula. Why? Because here lithium is first group element. It is a monovalent. Lithium charge is 1, but nitrogen charge is 3. That's the representation Li3N. In this compound, observe children, the oxidation state of nitrogen is -3. So here nitrogen combines with metals. The formation of the nitrides, nitrogen exhibits always negative oxidation state, that is -3 in this compound nitrides. Lithium nitride, nitrogen oxidation state is how much? -3. Like that. Nitrogen combines with magnesium metal, formation of the compound is magnesium nitride. In this compound also nitrogen oxidation state is -3. So examples of here, nitrogen combines with metals as well as it combines with non-metals also. Here the formation of the compounds are covalent nature. Nitrogen combines with non-metals, the formation of the compounds nature is covalent nature. But whereas here combines with metals, the formation of the compounds nature is ionic nature, because metals are high electropositive, nitrogen is high electronegative element. Then your electron difference is more, nature is ionic nature. But in this compound here, metal, non-metals are reacts with the nitrogen, formation of the compounds is covalent nature. So examples here given, nitrogen combines with hydrogen. Here hydrogen is a non-metal. Then formation of the compound ammonia. Like that nitrogen combines with one of the non-metal oxygen to form nitric oxide. So here nitric oxide ammonia molecule exhibits the nature is covalent nature. That is why nitrogen combines with non-metals. Mostly it behaves as the nature is covalent nature only. Okay, children? And next, these are the properties of nitrogen. Next, what are uses of nitrogen? So one of the uses it is used to manufacture of ammonia. That only already reaction knows. And one more is about manufacture of calcium cyanamide. What is the formula? CaCN2. Calcium cyanamide. CaCN2. Like that, you have prepared the many compounds. You are using the nitrogen gas. And one more use, it is used to create inert atmosphere. In especially in metallurgy process. Metallurgy means extraction of the metals. Sometimes we are creating the inert atmosphere. That time we are using of the nitrogen gas. That's why it is used for creating of inert atmosphere whenever extraction of the metals. That is also one of the use, children. Next, one more. Especially nitrogen in the liquid form. Generally, room temperature nitrogen is a gas. When compressed, means applying of high pressure, nitrogen gas will become converted to liquid form. That is why we are using liquid nitrogen used as a refrigerant. So in refrigerators, using of the nitrogen gas in the liquid form only, not in the gaseous form. It is used to preserve the refrigerants are used for preserve the biological materials, food items, and also using cryosurgery purpose. So these are the uses of nitrogen, children. Understand? So that is about the today now up to study here about preparation, properties, and uses of nitrogen. Understand, children? Okay, children, now go to study of here preparation of ammonia, properties, and uses of ammonia. Now, how to preparation of ammonia? Here also different methods are there. Here, one of the method, ammonia can be prepared by decay of nitrogenous organic matter. Decay of nitrogenous organic matter. Like example, urea is one of the organic matter. Here decomposition means then here ammonia is decomposition in water form the one of the intermediate compound is ammonium carbonate. This further interchanges formation of the product is ammonia. Here what happens? Equilibrium state is established. Means here conversion of ammonium carbonate to ammonia with water and carbon dioxide. Again here both here react and reproducing of ammonium carbonate also. That is why here reversible reaction takes place. This is one of the method preparation of ammonia. What is the method? Decay of nitrogenous organic matter like urea. What is the formula of urea? H2NCONH2. Next, one more method, especially in small scale ammonia can be prepared from ammonium salts. You are using ammonium salts like ammonium chloride, ammonium sulfate, etc. These salts reacts with your caustic soda. Caustic soda is nothing but sodium hydroxide, or with lime, nothing but calcium hydroxide. So ammonium salts treated with either caustic soda or lime. Then also you are producing a small quantity of ammonia. That's why you write the equation. Your ammonium salts can take example NH4Cl reacts with sodium hydroxide, that is called caustic soda, to form ammonia gas along with your sodium chloride and H2O. Like that, your ammonium salts of ammonium chloride are also using ammonium sulfate reacts with calcium hydroxide. Your calcium chloride is formed. Instead of sometimes you are using ammonium sulfate, their product is calcium sulfate. Calcium chloride or calcium sulfate with ammonia gas is formed. So this is one more method, children, preparation of ammonia. Next, whereas in large scale preparation of ammonia, especially in industrial methods, by using method is called Haber's process. The name of the process, Haber's process. In this process, the required raw materials are pure form of nitrogen and hydrogen gases, pure form, and as well as dry gases only. Now, a pure form of nitrogen and hydrogen gases both are passed into the tubes. Then what happens? Here the formation of ammonia gas. Here ammonia gas also decomposes to reproducing N2 That's why it is also one of the reversible reaction, as well as all are about reactants and products are gaseous phase only. That's why it is one of the example of homogeneous equilibrium reaction, children. N2 is gas, hydrogen is gas, ammonia is also a gas. So that's why it is a homogeneous equilibrium reaction. So now in this process formation of ammonia, what happens? Heat is liberated. That is why your delta H value is minus 46.1 kilojoules per mole. So heat liberated means the process of the forward direction is exothermic process. Understand? Study in equilibrium chapter applying of Lee-Chatler principle. So Lee-Chatler principle is applicable for equilibrium reactions. That is why it is one of the equilibrium reaction. Now applying the Lee-Chatler principle, what are the conditions are favorable? So here one of the conditions is temperature and pressure. Which temperature is favorable, children? This is forward direction. exothermic process because of heat is liberated. That is why, as per Le-Chatelier principle, for exothermic reactions always preferable for low temperature. I write here low temperature. How much temperature, children? Nearly 720 kelvins is the temperature. And also pressure. Pressure factor is mainly depends on number of moles of the reactants and products. Now you observe in reactant side total number of moles are 4 moles. 1 mole nitrogen, 3 moles hydrogen. Total number of moles of the reactants are 4, but product is 2 moles. Then what happens? Product sides are less number of moles than reactant side. Therefore, when applying high pressure on equilibrium, the reaction should be proceeds in forward direction only. Why? Because as per Le-Chatelier principle, applying of the high pressure, always the reaction is proceeds in less number of moles side. That is why here also applying of high pressure, the reaction is proceeds in forward direction. Therefore, to give the good yield of ammonia. Therefore, according to Le-Chatelier principle, here need which pressure, children? High pressure. Around how much? 200 atmospheric pressure. Even though applying of low temperature, high pressure, the yield is very less amount is formed. That's why to increase the yield, that means to speed up the reaction, to need for catalyst also. Here using catalyst is iron oxides catalyst like ferric oxide along with potassium and aluminum oxides also. That is potassium oxide formula K2O, aluminum oxide also. So these are acts as a catalyst. Simply here using the catalyst is iron powder or iron oxides with K2 and Al2O3. Here also the catalyst is a dull catalyst. You are studying surface chemistry. What happens? You increase the activity of the catalyst. You are using one more substance is called promoter. So, what is promoter, children? To activate the catalyst using the substance is called promoter. You are using the promoter is molybdenum. Is one of the transition metal. What is the symbol? MO. So the molybdenum, you activate the catalyst to speed up the reaction in both forward and backward reaction, then to give the good yield of ammonia. So that is the method is using here, manufacture of ammonia by Haber's process. Okay, children? So now as per Le-Chatelier principle, what are the conditions are required? Low temperature, that is 720 kelvins. High pressure, 200 atmospheric pressure. Catalyst, iron oxides with potassium oxide and aluminum oxide. Also using promoter, that is promoter is using as molybdenum. So these are the optimum conditions also called. So these optimum conditions are applied to give the good yield of ammonia, children. So this is the one of the manufacture method by Haber's process, children. So the total here study of 3 methods of preparations. One is decay of nitrogenous organic matter. Second one is ammonium salts are treated with either caustic soda or lime. Third method is a large scale manufacture of ammonia using Haber's process. Okay, children, understand? So you are applying of Le-Chatelier principles. As per Le-Chatelier principles here, temperature factor, pressure factor as well as catalyst is needed. You understand? So, but the principal equation is this one. It is very important, children. Ask the question, how to manufacture of ammonia by Haber's process. Write the principal equation and what are the required conditions as per Le-Chatelier principle. That is why first write this principal equation. So, in this equation, using pure form of nitrogen and hydrogen gases, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. So the reaction is a reversible reaction. The forward direction process is exothermic process. That means here heat is liberated. Therefore, as per Le-Chatelier principle, these are the conditions are made: low temperature, high pressure, as well as applying of here catalyst and promoter. That much of matter is needed for children. This is asking very important question. Around 3 marks are asking. Should write this concept of matter. Understand? So that is the preparation method of ammonia gas. So these are the various methods preparation of nitrogen. Okay. Children, now go to discuss about the properties and uses of ammonia. You see, what is the first property of ammonia? It is a colorless gas and pungent smell. Colorless gas as well as pungent smell. Like you are observed in the laboratory also available in the ammonia or ammonium hydroxide. Constant ammonium hydroxide becomes a pungent smell. Like when you are inhaling the your pain bomb, then like Jeddu bomb, you get the how smell like that. It is also some pungent smell. In ammonia gas converted into the solid form or in the liquid form, applying of pressure. So in solid form and liquid form states, here what happens to form the hydrogen bonds. That is called associative with the hydrogen bond. These hydrogen bonds are again two types are there. Intramolecular hydrogen bond and intermolecular hydrogen. Here the formation of the bond is a intramolecular hydrogen bond. In solid state or in the liquid state of ammonia exhibits intramolecular hydrogen bond, children. Next, the shape of ammonia molecule is a trigonal pyramidal shape. You studied first year also. Structure of ammonia. Here structure of ammonia. How is it here, children? Structure of ammonia. Here nitrogen. Here surrounding by 3 hydrogen atoms. Here one of the position is occupying lone pair of electron. Actually, is expected as tetrahedral. That's why tetrahedral geometry with one position lone pair of electron. Otherwise, the shape is called trigonal pyramidal. As per BSc-PR theory, here one lone pair, 3 bond pairs are there. Here the shape becomes is considered as trigonal pyramidal shape. That's why ammonia molecule trigonal pyramidal shape. It is very highly soluble in water. Why? Because it is also formation of hydrogen bonds. Formation of hydrogen bonds between water molecule and ammonia. That is called intermolecular hydrogen bond formation. So, due to highly soluble water, due to intermolecular hydrogen bond formation. And also, in aqueous solution, what happens? It behaves as a weak basic nature in aqueous solution. Because here ammonia dissolved in the water, formation of ammonium hydroxide, it dissociated into here NH4 plus and OH minus ions. That means ammonia in water, that is but aqueous solution producing of OH minus ions. So as per Arrhenius theory, here in aqueous solution producing of OH minus ions are behaves as base. Like that here also ammonia in water, that's why it behaves as a basic nature. And also it is a weak base only, not strong base. That is the properties of physical properties of ammonia. Next here, using of ammonia solution, nothing but ammonia gas dissolved in water. That is form the ammonium hydroxide. This ammonium hydroxide or ammonia solution reacts with the zinc sulfate solution, then form white precipitate, that is called zinc hydroxide. Generally, here salt analysis, identification of zinc ions using here ammonium hydroxide solution with the given salt. What happened immediately? White precipitate is occurs. That is also one of the identification tests for zinc ions. Okay, children, because your formation of the product is zinc hydroxide, it is a white precipitate along with the ammonium sulfate. It can be separated by using filtration method. That is common. Next, you are using again ammonia solution. That is ammonium hydroxide. You reacts with ferric salt, ferric chloride. Again, it gives a brown precipitate. What happened here? Brown precipitate is formed. That is called ferric oxide XH2O. So you know here rust of iron formula. What is the rust of iron formula? Fe2O3 XH2O. Here observe the rusting of the color of iron. Which color here? Rusting of iron. It is a brownish color. That is why here also precipitate is a brown precipitate is formed with the ammonium chloride. Understand, children? Like that. Now here ammonia also forms the complex compounds, nothing but coordination compounds is one of the chapters studied in second year only. That is called coordination compounds or complex compounds. So here ammonia in coordination compounds behaves as a ligand. Ligand means the substance which is donating of electron pairs to the central metal atom is called a ligand. Here ammonia, central atom of nitrogen, which consisting of lone pair of electron. That is why it behaves as a ligand in complexes. It is donating of electron pairs to the central metal atom. That is why here ammonia molecule forms the complexes due to presence of lone pair. So now I give the example here. Cupric salts. Like example can take CuCl2 or CuSO4, copper sulfate. Cupric, that is called cupric sulfate. The cupric sulfate is a light blue color. When it reacts with ammonia, what happens? Here the formation of the complex is a deep blue color of the complex. But what is the compound here? Tetra aqua copper ion. Tetra aqua copper ion complex is formed. So you are using 4 moles of ammonia, that is called tetra. So this is a NH3 amine. So not aqua, tetraamine copper ion is formed. The name of the complex as per IUPAC system. So the color is a deep blue color is formed. And next, children, again you are using of silver ions and chloride ions combined together to form a white precipitate of silver chloride. It is a solid substance. Now the precipitate of your silver chloride, again what happens, children? Yeah, white precipitate of silver chloride again treated with ammonia liquid again also forms the complex. But this complex is a colorless complex. In before what happened? It is a white precipitate. Whenever treated with ammonia liquid, it gives the complex salt. So the complex of the salt name is here using this is a diamine silver 1 chloride. Because of this part is a cationic part. The cation charge is complex is 1. Here this is negative ion. So always whenever write the name of the complexes, cationic part first write. The name of the complex cationic part is diamine Ag means silver or argentinium 1 chloride. That is the name of the complex. The complex is a colorless complex. What is the name of the complex, children? Diamine argentinium 1, Roman number 1. Always oxygen states are expressed in Roman numbers. And anion part is chloride. That is the name of the complex. So, these are the chemical properties as well as physical properties of ammonia, children. Next, I want to tell about the uses of ammonia. Ammonia gas is one of the most important raw material in the manufacture of fertilizers. So what fertilizers are manufactured? So like preparation of manufacture of urea, manufacture of ammonium sulfate, manufacture of ammonium nitrate, manufacture of ammonium phosphates. These are fertilizers are prepared by using the raw material of ammonia gas. What are, children? Urea, ammonium sulfate, ammonium phosphate, ammonium nitrate. These are the fertilizers are prepared by using ammonia gas. And one more is also manufacture of nitric acid also using ammonia gas, children. That is using ammonia gas. Next, here ammonia, liquid nitrogen and liquid ammonia gas is also using as a refrigerant. Like earlier also using liquid nitrogen used in refrigerants. Like that liquid ammonia also used as refrigerant. Understand, children? So these are the uses of ammonia. So now in this video to learn about the nitrogen and ammonia, these two compounds, preparation, properties and uses. Okay, children? Yeah, the reactions are very important, children. How we are asking reactions here? Here ammonia solution reacts with zinc sulfate. Here the formation of the precipitate. Here given the dash. What is the dash? Like ferric chloride reacts with ammonium hydroxide. What is the product formation? Like this. Silver chloride here reacts with ammonia. Formation of the complex is a formula. This one complex. It is a colorless. like this. Cupric salts reacts with ammonia. The formation of the complex is a deep blue color. What is the part of the complex? And what is the oxidation state of copper? Your copper oxidation state is how much, children? +1. Like this, your silver oxidation state is how much, children? +1. So this cuprous complex is formed. It is a argentinious complex is formed. So these are the properties of your children ammonia. Okay.